Hello, welcome back to KISH-CAT classes. My name is Kishore Kumar. I'm the founder of KISH-CAT classes. In this session, we are going to learn power cyclicity that comes under numbers chapter, and we are going to specifically focus on unit digit. Power cyclicity is very familiar for every student. We have learned this one during our high school days. Let's see what is the weightage of power cycles in CAT exam, and also let's see what types of questions are going to be asked in power cycles. This graph gives you a comprehensive idea of the numbers questions asked in the last 25 years, the weightages for different concepts. Now, if you look at this one, this is power cycles. The 6 is the number of questions appeared in the last 25 years of CAT, and it's equivalent to 3%. Now 3% is very limited and 6 questions are also very low. But if you pay closer attention, it's not just it's about 3%. It's about when they appeared. The power cycles appeared in 1990s one time, in 2000, mid of 2000, exactly 2005, in 2007 it appeared, 2008 it appeared. In the last 4 or 5 years, exactly in the last 3 years, it appeared in every single paper. So this means it is very important for the coming CAT exam. Let's see what types of questions are going to be asked in power cycles. Now power cycles is very simple. We have a number n raised to power p, and we will get different unit digits, different numbers actually. So n raised to some power p, and we just need to see what types of questions are going to be asked. Like n raised to some power p, we get a very big number. We need to check its unit digit. We need to find the last 2 digits, and we need to find the first non-zero number from the unit digit. So these are the only 4 types of questions. The most important one among all these 4 is last 2 digits. This video I'm going to teach you unit digits, and in the next video I'm going to teach you last 2 digits. Let's see how to find the unit digit of a number. When we have a number and it's raised to power, and since we need to find its unit digit, the remaining digits are of no use for us. Let's see how to find a unit digit. Now we have got 10 digits. That's going to be 0, 1, 2. I don't simply explain what is power cycles and then quite simple. I'm going to explain you the story and I'm going to explain you the process to identify the power cycles. Now, when we have got digits like 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, when we raise a number to any power, we're going to get one of these 10 digits. That's quite simple. Let's see what should we do. So we've got n power p. N is a flexible number. P is also a flexible number. So we can say 2 cube. Then the next time we can say 3 power 4. Now this could be a fixed number also. We can start with a fixed number, and then power is also fixed. So we have got many possibilities here. And also we can take any number in the place of a fixed number. Let's start with 0. Now 0 power any number, that's 0 power 7 or 0 power 3 or 0 power 0. For these numbers the answer is 0. Why it is 0 is quite simple. It's like 0 power 3 is nothing but 0 multiplied with itself 3 times, that becomes 0. And for this number 0 multiplied with itself 0 times, that's not possible. That's why it is undefined. So we have got only 2 answers. Either it's going to be 0 or undefined. So we don't get this question. And it's going to be very simple one. So what happens if we take 0 in the power? That's going to be 7 power 0 or 3 power 0 or 21 factorial power 0. That is nothing but 1. It's even simpler. There is only one single answer. So 0 is of no use. Let's take 1. 1 power 7, 1 cube, 1 power 234 factorial. For all these numbers, answer is 1. That is also of no use. Let's do the reverse process. 7 power 1 or 3 power 1 or 234 factorial power 1. That is nothing but the base itself or the number itself. So where is the cycle here? It may come when we try to take 2 or when maybe for 3. Let's see some experiment. Now digits are like 0, 1 and 9. So let's take n power 2. So we fix the power and we take a flexible number and it's a fixed one. Fixed one is like we have already fixed it 0. Now 1 square is going to end with 1. 2 square is going to end with 4. 3 square is going to end with 9. Very good. We have got at least 3 different unit digits. What about 4 square? 4 square is going to end with 6. 5 square is going to end with 5. 6 square is going to end with 6. 7 square is going to end with 9. 8 square is going to end with 4. 9 square is going to end with 1. 10 square is going to end with 0. We have got more. But if you pay closer attention, not every digit is appearing, and also if at all if some digits are appearing, their occurrence is quite disturbing here. It's not that every single term is appearing the exact number of times. No. So this experiment provided us absolutely nothing except one outcome where the square of a number never ends with 2, 3, 7, 8 as its unit digits. So n square, the square of a number, the unit digit of it cannot be 2, 3, 7, 8. So this also provided nothing. So let's see what we can do is like we will do the experiment in a different way. Let's take 2 here and let's change the power, and the power also we take in a proper sequence. No, if it is not a proper sequence, like one time we take 2 cube, next time we are going to take 2 power 8, next time we are going to take 2 power 10, that doesn't solve that doesn't provide the solution. So we'll go in a proper order. Let's see. So now 2 power 1 is nothing but 2. 2 square we have got 4. 2 cube we have got 8. 2 power 4, even though it is 16, the unit digit is 6. 2 power 5, it is 32, but the unit digit is 2. 2 power 6 is 64, unit digit is 4. 2 power 7 is 128, unit digit is 8. 2 power 8 is 256, unit digit is 6. Now 2 power 9 is 512, unit digit is 2. 2 power, I'm writing only up to 2 power 10. Now do you see any pattern here? Do you see any, have you observed any pattern here? Yes, there is a pattern. So it's going to be in a proper order 2, 4, 8, 6. Next time also it's appearing 2, 4, 8, 6. Again it's appearing 2, 4, then it must be 8 here, then it must be 6 here. There is a cycle actually. The unit digits are going to be even because we have taken an even number in the base, and power is going to be any number. But if the power is in a proper order, proper sequence starting from 1, so that's going to be 2, 4, 8, 6 cycle. So it is 2, 2, 2, then 2 power 13 is going to be 2, 2 power 17, and so on. So we have got 4 different unit digits when 2 is raised to some other number, some power. Now let's find what is going to be 2 power 100 here. We cannot manually count 2486, 2486, 2486. In such case, what you can do is like you can take 100 power, because for every 4 terms the cycle completes in every 4 terms, and the new cycle will start at the 5th term. In such case, we can divide this number by 4 and then we find the remainder. Now the remainder is 0. When the remainder is 0, obviously it is going to be the last term of the cycle. So it means last term of the cycle is going to be 6 here. Let's focus on 2 power 123. Now we need to divide this number with 4. We have already learned from divisibility rules that if at all if a number is divisible by 4, that is of the form 2 power x. It depends on the last x digits of the number. Here the number is 123 and the last two digits are 23, so that's going to be 23 by 4. The remainder is 3. When the remainder is 3, it's going to be third term, that is 2 cube, that's going to be 8. So let's say if it's going to be 2 power 1, 2, 3, 4, 5, 6, 7 and it's unit term. What we need to do is like we need to divide this one with the number of different unit digits that we get in a 2 cycle. So the remainder depends on last two digits, that is 67 by 4. So the remainder is 3. So if when the remainder is 3, we need to take the third term in the cycle. When the remainder is 1, the first term, remainder is 2, the second term, remainder is 3, the third term. Remainder can't be 4. Whenever a number is divided by 4, the remainder can't be 4. The remainder is going to be 0. Whenever the remainder is 0, we need to take the last one of the cycle. So taking this order, that is base fixed and then power in a proper order, we are getting a cycle. Let's see whether it is possible for other number. We start with 3. 3 power 1 is 3. 3 square is 9. 3 cube is 27, so it is 7 here. 3 power 4 is 81, it's 1 here. 3 power 5 is 243, it's 3 here. 3 power 6 is 729, it is 9 here. 3 power 7 is 2187, it is 7 here. 3 power 8 is 6561, it is 1 here. Do you find any pattern here? Obviously there is a pattern, that is it is 3971 and again it's coming as 3971. Since 3 is an odd number raised to any power, we are going to get odd number. So the digits are 3971 and it's 3971 in a proper order. Now for 3 also, we found that this pattern gives us a proper direction. Now if you are trying to find like 2 power 234 unit term, so that is 3 power 234 by 4. Why 4? 4 is because the number of different unit digits that we get in a 3 cycle is 4, so we need to divide the power with 4. So the remainder depends on last two digits. 34 by 4, the remainder is 2. If the remainder is 2, then it is the second term of the cycle. Now you can do it for every number. Like 4 power 1 is 4. 4 square is 16 is 6. 4 cube is 64 is 4. That's it, enough. The cycle is completed already. Whenever you get the term that is 1 as the unit digit, the cycle is completed, or whenever you get the first term, cycle is already completed. There are two ways. One, once you know that the unit digit of a particular number raised to a particular power is 1, then the cycle is completed. For all the even numbers, once you have done this process, at some point of time you find that the first term is again repeating. That's it, it's over. So for 4 power cycle, it's 4 and 6. So like this, 5 power 6, 6, 7, everything you can find quite easily. So I do it for 5 power 1 is 5. 5 square is 25, so that's 5. So it means that there is only one. 5 raised to any number, we're going to get 5 only. Let's take 6. 6 power 1 is 6. 6 square is 36. That is 6. So we're going to get only one term here. Let's start with 7. 7 power 1 is 7. 7 square is 49. 7 cube, that's maybe a bit difficult to see what is 7 cube, that is 343. 7 power 4 is, again it's a bit difficult to identify that all the digits, that is 2401. Whenever 1 has come, the cycle is completed. Now the task is not to find 7 cube and 7 power 4. The task is to find 7 cube unit digit and 7 power 4 unit digit. Instead of trying to find 7 cube whole number, the entire number of 7 cube, we just need to focus on unit term. Let's see how to find a unit term here without finding the remaining digits. 7 cube is nothing but 7 square into 7 power 1. 7 square we know that it's 49. 7 power 1 is nothing but 7. Now I'll take it manually. 49 into 7. 7 into 6. 7 into 9 is 63, that is 3. 6 is carry over. No matter what happens, the remaining digits come here. These are of no use. We need to focus only on it. Now, to find the unit digit, what we have done is we have multiplied the 7 square unit digit with 7. So it means we need to just focus only on the unit digit of any number. Now to find 7 power 4, we can directly take 7 cube unit term into 7 power 1. 7 cube unit term is 3. 7 power 1 is 7. 7 into 3 is 21. That is 1. That's it. A number into the previous number raised to some power, the previous power unit term into the number again. We'll get the unit digit of the current number. So if we apply the same one, 8 power 1 is going to be 8. 8 square is nothing but 8 into 8, 64, that is 4. 8 cubes is nothing but 8 into the previous number unit term, that is 4. 8 into 4 is 32, that we can write it as 2 here. Now 8 for 4 is nothing but 8 into the previous term unit digit, that is 2. 8 into 2 is 6, that is 6. 8 2s are 16, that is 6. 8 power 5 is nothing but the previous term unit term, that is 6 into 8, that is 6 into 8, 40 is 8. Now we have got the first term again. So no need to find all the digits actually. To find the unit digit actually, we need to multiply the number with the unit digit of the previous number, which is like raised to some power. That's it. This is going to be very simple. Unit digits questions are not appearing in CAT. In the last 5-6 years I haven't seen. In the last 1 decade also I haven't seen even a single question. In the last 10 years the primary focus was to find the last 2 digits. This is the cycle. Now I'll show you. This is the entire one. 1 raised to n. We'll get unit digit is 1 and its cycle size is 1. So I've written for all 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I have written only for the first 10 numbers. I haven't. This is not for 11, 12, 13. Let's see what really happens. Instead of a single digit number, if you have a 2 digit number, raise it to some power and we need to find its unit digit. So n power p is very easy if n is a single digit number. However, if it is like some number like n1, n2 power p, then we need to find. Let's take how to find. So let's focus on some 2 digit number. I'll start with 12. I'm not ready with 11 because 11 of some number is going to end with only 1. So let's take 12. So 12 power 1 is 12. 12 square is 144. That's 4. 12 cube is 1728. That is 8. Now it looks like that it is matching with 2 power some number. Let's check. 2 power 1 is also 2. 2 square is 4. 2 cube is 8. Both are matching here. The common thing is like second one is a unit term, second one is a single digit number, and then first one is a 2 digit number. However, the unit digit is same. It's matching with the 2 power 1, 2 power 2 square 2 cube. Now why this is occurring is quite simple. It's like 12 square is nothing but 12 into 12. Now if 12 into 12 means 2 into 2 is 4. Now the remaining digits will appear here in tens place, hundreds place. However, we don't need all these things. We just need to focus on this one. So to find the unit digit of a number, we just need to take the unit digit of any bigger number. So we can write like this. If you want to find, let's say A, B, C, D whole power, let's say some number P, Q, R and its unit digit, then we don't need this part. We need to focus only on this D equal to, that means it is D power PQR. D is nothing but its unit digit. That's it. Now I've given exactly 10 questions here. 10 questions where you need to find the unit digit. You can solve all of them. If you want all these 10 questions in a single worksheet, you can get the worksheet from KISH classes Facebook page. I suggest you to solve all these 10 questions and then you can watch the video, that is the solution video for all these 10 questions. So the next one, I'm going to make the next video is going to be solutions for all these 10 questions, and the next concept video is going to be on how to find the last 2 digits of a power cycle. Thank you.